What parts of the lesson do you anticipate that your students are going to find straightforward and be successful?
I think what will come natural to the learners is, first of all, the number talk. I think we'll probably go through that pretty quickly. And moving into the second phase of the lesson, looking at learner work, I think the similarities and differences will jump out at them right away. I think they'll struggle a little bit with some of the multiple representations. I think, and it's going to be different for all of the different learners in the classroom. So some of them are going to struggle, I think, maybe with the verbal description and how to use words to describe the pattern growing. And I think other learners will have more of a challenge at modeling how they see it growing. My hope is that the XY, I think the in and out table will be easy for them to see the clear connection between the in and the out. But I would anticipate a little bit of a struggle with pulling that T-chart apart and looking at the mathematics behind how the learners see it growing.
Well, it's sounding like your focus is really on multiple representations and multiple solution strategies, and that's what you're hoping will come out of the lesson for your students today?
Yes, I'm really hoping that the learners will take to heart multiple representations for modeling different functions and that we can apply this in future lessons. I mentioned before that I don't think graphing will necessarily happen today, but that is kind of the next step of this lesson, is to really dig deep with the graphical representation of both of these rules and just to kind of have a complete picture of these two different functions that learner A and learner B came up with, describing the same pattern. And how could we have two different functions that describe one pattern?
Can you talk to us a little bit about what your next steps will be after this lesson?
My intention is that this is the start of a year-long study of multiple representations and being able to use multiple representations throughout the year to enhance our understanding of algebraic situations and functions. So I'm really looking forward to exploring in the future the border problem and some tables problems and things like that. So just kind of getting into more growth patterns as the year goes on and exploring those representations with those patterns.
One of the advantages I see, or one of the strengths of this, is when you're going to expand your T-chart and let them show what they're thinking using the numbers. What's the relationship between the input and the output? And then hopefully where they're going to go with this eventually is to start to make some abstractions from their computations. What are they doing over and over in each one of these input-output pairs, and be able to generalize some sort of rule?
That's a good point that I didn't really speak to, was the generalization piece. I did mention that in the learner work that they were fairly successful at being able to generalize, but most of them were generalizing with arithmetic. They weren't generalizing with maybe a variable or making some kind of relationship between y and x. So that would be another outcome that I would be looking forward to, is generating rules that look more traditional, have that y equals mx plus b format, so that we can start applying that to further graphing lessons and just building our understanding of algebraic reasoning as we get ready for 7th and 8th grade.
One of the strengths of using patterns as an entry point to algebraic thinking is that the kids can start to see the same thing happening over and over, and then trying to come up with the language to describe what's happening. One of the things you said that they were going to struggle with is maybe a verbal explanation of what was going on, and to give them the ability then to move from that verbal to some sort of symbolic representation, and to be able to describe a function symbolically or using an algebraic expression or algebraic equation is something that's going to be really powerful for them, and patterns are such a great entry point for them to do that.
And I agree wholeheartedly with the idea of making the mathematics explicit by pulling the T-chart apart and representing it numerically to let them make the connection between the input and the output. My question is, do you anticipate that aha coming from the students as a result of this lesson, or maybe further down the road, that the input and the output look the same and the graph looks the same, but the way that the student A and student B saw the pattern was different, yet got to the same end result? And so maybe even though the rules, if they get to that point, look different, the rules are equivalent. Is that an anticipated?
That's an anticipated outcome. So yes and no to the question. I think, yes, I want them to see the mathematics behind the pull apart. And that's where I'm going to focus today. I don't know that they'll see the equivalency in the graphing, because that's something that will be hit or miss as to whether learners get there today. But it's definitely where I'm heading. I want them to make that leap. And I don't know at this point in the school year that, yes, we'll get to looking at the equivalency between two different rules, but I do anticipate that eventually, somewhere down the road, we'll get there.
Friend, thank you so much for letting us come into your class and watch this lesson.
My pleasure.